Thought I'd do a quick little demo to show you just how easy it is to exploit this Log4j problem, why it's so widespread, and why it's so dangerous. So we'll start with a simple Java web application. This one's written with Spring Boot, and all this application does is take data from the HTTP body and log it. Now, to use this vulnerability, it could be anything, any data that's under the attacker's control, as long as it gets logged. So you don't have to be authenticated. It could be a header or a cookie or a URL parameter, or a form field, anything that's under the attacker's control that gets logged could exploit this problem. So first, let's just use this application normally. So we'll go here and we'll just invoke this with a curl request here. And we're just going to send test data demo, right? So we'll send that data in. Okay, great. That's, we're just verifying that it actually works. Now, to exploit the vulnerability, we're going to replace this test data demo with a carefully crafted string that will trick Log4j into loading a malicious class. Here's how we do it. First thing we do is we start a malicious RMI server. This will send a malicious class file when requested. So I'm going to copy this link here to the malicious class file. And now we just need to trick Log4j into sending it. So we're going to go back to our curl here. We're going to replace this one with the new key. So what this says is this template right here tells Log4j, hey, go do a JNDI lookup, look it up over RMI, and pull this malicious class file down and then execute it. So let's run that. That's exactly what happened. So we tricked this Java web application into running whatever code we want. It's a full remote code execution. That means as an attacker, I could create a shell here. I could use this as a launching point for other attacks. I could run ransomware. I could do anything I want, steal the data or the code that's on this machine. It's devastating. And as you can see, it's just one simple request to exploit this vulnerability. So now let's take a look at what this looks like if you're using Contrast. So let's stop this web application and just turn on Contrast. So the first thing we're going to do here is we're going to download the Contrast agent. So here we're just downloading a jar file. We just downloaded this contrast.jar from Maven Central. And then we're going to tell Java to use this jar file. So here's how you tell Java to use this Java agent. And I have a little configuration file here that's got my credentials in it. That's it. We'll set that environment variable. Then we'll run the application the normal way. This time, when it started up, you can see Contrast loaded, and it instruments the application, and it starts assessing the application for vulnerabilities and analyzing all the open source libraries, as well as protecting this from exploit. All that happens in the background as you use the application normally. So now, let's go back and let's try using this application normally. We'll put test data demo 2 here. So now, Contrast saw that request, it traced all the activity, and we can look up this application in the Contrast application inventory. We'll go down to the Log4j demo here. We'll pull that up. We can see we're running this on a production server, so where all our information is here in production. Contrast already analyzed this application for vulnerabilities. You can see we discovered a log injection problem. That's the one we're focused on. But we also found a couple other little problems just by using the application normally. Here you can see exactly what Contrast saw. We saw data come in, this test data demo 2. We saw it flow through the application into this example class, flaky method, line 25. And we saw the whole message that got logged here. When we look at the details, it gets really interesting. This shows, the exact line of code where this was read in. We can see how that data flowed through the application, and we can see here where this application called Log4j to log this. And when we look at this, we can open this up and we can look at the, all the data and the stack trace here. So that's good. This, Contrast told you this several years ago, probably, and told you you should fix your log injection problems. If you'd done that, you'd be safe. However, most people didn't do that. So we can look on the libraries page for this application here. And Contrast also just analyzed all the libraries in the application and identified that, hey, you're using an out-of-date version of Log4j 2. See, 2.14.1 is the most recent vulnerable version. They just issued 2.15 here to fix this problem. And you can click in to any of these to see the details on exactly the CVSS and everything. You can also find out exactly what applications are using this vulnerable log4j jar file, and you can see exactly what servers it's running on. Let's take a look at actually attacking this now. So we'll send the same attack that we sent before and exploit this, but now you'll notice that the calculator didn't pop up. That's because Contrast Protect intervened, and it said, hey, we see an attack in progress. We're going to intervene and prevent that attack from succeeding. So let's take a look at the Attacks tab here. Here you can see that Contrast identified the attack that just came in, and I'll click on this to drill into the events. And when we open up this event, you can see, hey, Contrast saw an expression language injection event, and that's actually what the malicious class that the RMI server served up has an expression language injection attack inside it, and that's what ended up getting exploited. Here you can see the HTTP request that caused this. We traced that through all the way to the expression that got evaluated, and here you can see a malicious expression designed to call runtime.exec and open the calculator app. When we look at the stack trace, it gets really interesting. You can see all the way from where we called the logging API, all the way through the application, you can see that the logging API calls JNDI to look up the name. That actually invokes the RMI call. And then eventually we get the data back. And you can see here's where we call the expression language processor and evaluate that expression, ultimately causing this expression language injection attack to run. So to sum up here, this is a super dangerous attack. It applies to almost every Java application that's out there, anything that takes untrusted data and logs it, which is just about everything. It's going to be really difficult to deal with this if you're scanning for it or try to fuzz for it. It's much easier to use Contrast to find out exactly where these libraries are used and where they're active. And of course, you can always use Contrast Protect to make sure that if you do have applications with these vulnerabilities, you're safe in production until you can go back and get them fixed. If you need more information or would like some help working through this, please don't hesitate to reach out to me on LinkedIn. I'm Jeff Williams, the CTO and co-founder at Contrast Security, or visit our website at www.contrastsecurity.com. Thanks.